Area and Perimeter, Polygons and Quadrilaterals by me, Mechel, Bynoe, Ramos. Definition of concept. Now I chose to do 4 different definitions of each of the concept. Now a polygon is a plane figure with at least 3 sides and angles, typically 5 or more. A quadrilateral is a 4-sided figure having straight sides. An area is a part of an object or surface, and perimeter is a continuous line forming the boundary of a closed geometric figure. Now I want to give you a quick explanation of the concept. The concept of an area and perimeter is to figure out the measurement around a plane or figure of the polygons and quadrilaterals. Doing my research, I figured that's as simple as it's going to get, and why make it be more complex than what it actually is. Calculations of area. In this section, you see 3 polygons listed: rectangle, square, and triangle. And within the 3, there are 2 quadrilaterals, which is the rectangle and square. And you see that their area formula are similar, using A equals length times width. However, under triangle, its formula for area is completely different, using 1/2 base times height. And that's because a triangle is a 3-sided figure. So here you see listed A, B, and C. Seeing that A and C are the sides with the measurement of 10 meters, and the base being B, which equals 15 meters. And you see where I had to multiply 1/2 of the base, which is 15 meters, times the height, which is 10 meters, and you see that I have come down to having the area equal 75 meters square. Calculations of perimeter. Now in this section, you see those same 3 polygons, and you see that the rectangle and square has the same perimeter formula versus triangle has a different one, just like in calculations of area. With the rectangle and square, you see that the formula is perimeter equals 2 times length plus 2 times width. Now with the triangle, you see that perimeter equals A plus B plus C, and that's A equals one side, B is the base, and C equals the other side.
Just add, it's all around the outside. It's good, perimeter's the outside. Area means the inside. Cover the surface that's inside. Squares. I'll just make sure I inside. It's the area that's good. The area's the inside. Multiply. The area's the inside. It's good. Square units on the inside. Outside, but just add, it's all around the outside. It's good, the area's the inside. Multiply, square units on the inside.
The history. In this section, we talk about 5 fun facts about the history of polygons and quadrilaterals. Now, the first subject you see is about the hero of Alexandria, and he's also known as Heron. He was an ancient Greek mathematician, and he's the inventor of creating the formula for area and perimeter of polygons. Another fun fact is he lived in the 2nd century BCE or either the 3rd century BE. The exact time is unknown. However, he did write a book called Metrica, and in the book he wrote about his findings of perimeter to decipher the area. How cool is that? Now, the third fun fact is about 3D polygons called Platonic solids, which were discovered by Plato, who is a Greek philosopher, and in which the Platonic solids were named after. He discovered that there are only 5 polyhedras, which are 3D polygons. Another fun fact is about Archimedean solids, which are regular polygons that are 3D, which is identical on each side but have more than one shape. That's awesome. And Archimedean calculations of area and perimeter were used to create many of the pyramids in Egypt and other buildings and objects in Greece during his era of time, which now relates to a lot of different things in today. Full cell careers using polygons and quadrilaterals, area and perimeter as well. This was a really fun part for me because it's involving my career, which is computer animation and also game art. Computer animation and game art both uses a program called Maya, and in this program it used polygons and quadrilaterals to sculpt modeled characters, scenes, and other objects using various tools and methods within the program. Also, Plato and Archimedes' concepts of 3D polygons are used in both degrees in the program Maya. The use of area and perimeter gives a real-life measurement of the scenes created for animation and games. Now here you see an example of a real skyscraper and the lengths and the measurements of it. Now you see that down below in the blue section I have the answer for perimeter and area. Modeling scenes and characters is imperative that we understand basic math and concepts such as area and perimeter polygons so that we can reflect what we create back to real life. And in here you see the reference page.